Very warm welcome to all. I am Dr. Manoranjidam, working as Associate Professor, the Department of Computer Science, SRM University. In today's topic, we'll see the migration of IP networks to software-defined network. Why we have to migrate from IP network to software-defined network. First, we'll see the basics of IP network. What is meant by IP network? IP networks are networks which uses IP addresses to connect devices and enable communication on a network. IP networks use Internet Protocol to route packets. IP networks are the foundation for Internet, local area network, WAN, MAN, and so on. This IP network uses the Internet Protocol. And this Internet Protocol, there are two versions. One is version 4, the other one is version 6. Next, we'll see what is meant by an IP address. IP address is nothing but a unique identifier or a number that is assigned to every devices connected to Internet. No two devices on the Internet can have the same IP. Devices on the network, they need three information to correctly communicate. One is the IP address, the other one is the subnet mask, the third one is the broadcast address. This IP address is the size is 32-bit and it is represented as dotted decimal notation. The main use of subnet mask is the subnet mask has two parts. The first part identifies the network. The second part identifies the host in the network. Now we'll see what are the limitations of the existing IP network. The first limitation is in the IP network, the data plane is integrated with the control plane. Generally, in IP network, there are three planes. One is the data plane, the control plane, and the management plane. Here, the data plane is tightly integrated with the control plane, and because of this, the standardization of protocol is very slow, and we can say that the hardware is bundled with software and the interfaces are vendor specific. And the other limitations are innovations are done only by few people, codes are written by equipment vendors, and introduction of any new features takes a lot of delay. And another reason is equipments have lot of software errors. You call them as software bugs. And the rate of innovation in networks is slower and they lack high level abstraction. Configuring the networks according to predefined policies is difficult. And it is very hard to restructure and configure the network in case of any fault and if there are any load changes. If the load is very high or the way load is crosses the threshold. And using the proprietary networking devices with the proprietary software and hardware, innovation is very much limited to vendors and their partners. And these are the reasons why we have to migrate from IP network to software defined network. Here in the figure, you can see that this is an IP network. The last layer, you see a data layer. On top of this, you have the control plane or the data control plane. On top of this, you have the management plane. So in an IP network, this control plane and data plane are tightly integrated. And you can see that many complex functions are baked into the infrastructure. Infrastructure here is nothing but your control data plane. That is open source shortest path first, BGP, multicast. All these are routing protocols, traffic engineering, NAT, firewalls. All these are baked inside the infrastructure. And you cannot dynamically change in case the network changes. So these are the reasons why we go for this software-defined network. So in software-defined network, the control plane is separated from the data plane. So you can see the architecture of this software-defined network. So this is your data plane, this is the control plane, and this is the management plane. So you can see that the control plane is detached from the data plane, and in the data plane you have only the network switches. This network switch does only the forwarding part, whereas the control plane controls the data plane, and the control plane is otherwise called as controller. And top of the control plane, you have the network plane, management plane, where different network applications run. And you can see that the control plane is connected to the data plane using open southbound API. And the control plane is connected to the management plane or the network applications using the northbound API. API is nothing but application programming interface. And the standard open southbound API is nothing but your open flow protocol. You call it as open flow protocol. Whereas the open northbound API, the standard API is REST API. Now, whenever routing has to take place, the controller takes control over and it tells you or gives direction to the data plane how to route the packet, from which node it has to go, and what is the destination. All these informations are sent by the controller. So the heart of your SDN is nothing but your controller. There are different types of controller. You have Knox controller, POC, which works on C++, programming language C++, and you have POX controller, which is based on Python, and you have another controller called as Open Daylight, which is based on Java. So these controllers, any controller can be used according to your applications or your requirements. And this controller maintains a flow table, and this flow table will look like this as shown in the figure. So the flow table entry will look like this. It has got three parts. One is the matcher, which gives you details about the source address and destination address. One is the MAC source address, the MAC destination address, the Ethernet type that is used, the virtual LAN ID, the IP source address, the IP destination address, the Internet Protocol version, the TCP source port address, and the TCP destination port address. So these are the matcher has only the MAC address and the IP addresses. When you take action, this action tells you the controller will give you what action has to take place in the data plane. That is, the first action, it can be either forward the packet to any port, you encapsulate and forward to the controller, or you drop the packet, or whether you have to rewrite the header or map to the key. Whereas the counterpart, the third part, it encapsulates the packet plus the byte counter. When you come to the topology of your SDN, it uses star topology. You can see this is your data plane. The data plane has got only the switches. You call them as open flow switch. And this data plane is separated from your control plane. The controller or the control plane gives you in directions to your open flow switch what operation it has to perform. And to this open flow switch, you can find that you have n number of servers and clients which are connected. Depending on the directions given by the controller, forwarding takes place in the data plane. So the main advantage of using SDN is the hardware is completely separated from the software. The software is nothing but your controller. And top of the controller, many applications you can run, like load balancing applications, dynamic load balancing, static load balancing, all that. And because of this, it is very dynamic. You need not change the hardware. If you want to make any modifications, the hardware need not be changed. You can just reprogram and use it. Thank you. We'll see in the next lecture.